Hey guys, and welcome to another lesson where I'm going to cover exam objective 2.6, and we're going to learn everything we need to know about configuring basic wired, wireless, small office, home office, otherwise known as SOHO networks. I'm going to tell you about all this stuff. I'm going to tell you everything you need to know. I'm going to tell you what kind of questions they may ask you on your exam, and then I'm going to give you some practice multiple choice questions for your exam as well that you can use to make sure you are actually ready to take this thing and pass this thing like I know you will. So let me put my seeing goggles on and we'll get straight to it and give you everything you need to know as quickly as we possibly can. Ready? 3, 2, 1, let's go. The first thing we're having a look at is the general concept of IP addressing or Internet Protocol addressing. So look, you can read these notes if you want. Pause and have a read, but I'm basically going to zoom in over here to take us through the general concept of IP addressing, right? Think of IP addressing as a house, right? You've got your house that you live in. You live in this house. No, you don't literally live in this house, but for the sake of it, like, don't go to this house. This doesn't exist. This is on a computer in the cloud. You'll get lost, all right? But for the sake of example, you live in this house. And within this house, you have all of these different devices, okay? So the way IP addressing works is you have a public IP address. This is essentially the address that your router puts out to the world, okay? So you've got your private IP addresses. So every single device in your house has a private IP address, and your router has a public-facing IP address. So the whole world, everyone in the whole world accesses your home through your router's public IP address. And what your router does is it receives that data and it sends it to the device that needs it by sending it to that device's private IP address, okay? So the general idea that you need to understand is that IP addresses is just a way for data to reach the correct device over the network, over the internet. And you have public IP addresses, which are visible from the wide area network, visible from outside your network. And then you also have private IP addresses, which are only visible from within your local area network, okay? That's the main concept you need to understand. So, as it goes through here, IP address is kind of like your home address, but for devices. It's the unique label that helps computers, phones, or any gadgets on a network find and talk to each other. So private is within your network, public is visible from outside your network, but outside network can't see your private devices. That is, in fact, private. All right, so you got public and private. That's the main thing for now. All right, so some specific types of IP addresses we need to know about and be able to identify. The first one is IPv4. Okay, IPv4, we've got 32-bit addresses divided into 4 octets. So what that means for you, for your exam, you're pretty much going to need to be able to say, look, here is an IP address. Is this IPv4 address? Is this IPv6 address? Is this a MAC address? What kind of address is this? You'll need to be able to look at it and say, oh, this is an IPv4 address. How do I know? All right, let's make sure we know how we know. IPv4 will have 4 numbers, each of which will be separated by a dot. We've got 1 dot there, 1 dot there, and 1 dot there, okay? That's largely it. That's how we can note that it is an IPv4 address. If it has a letter in it, it is not IPv4. If it has anything else other than a number from 0 to 255, it is not IPv4, okay? So this is what an IPv4 address looks like. Get used to it, make sure you know it, and know that it uses 32 bits. It is a 32-bit address, all right? Now, the general concept behind IPv4 is it's what we've used for a long time, but because it is only 32 bits, its address space is limited, okay? So we are kind of starting to run out with all these unlimited devices we're putting into the world these days. We need a little bit more space, okay? We need a little bit more space coming up, and that's what we'll get into in a bit when we look at IPv6, but there's a couple of different sub-classifications of IPv4 that we need to know about and some more details, all right? But for IPv4, just that's what it looks like. It's got the 1, 2, 3 dots. It's 4 numbers separated by dots. The numbers are from 0 to 255. It's a 32-bit address. That's pretty much it. Just make sure you can identify it and know that one of the downsides is we're starting to run out of space with it. We're needing more space. Now, IPv4 addresses are separated into 4 different classes, or 5 different classes really, but we've got different classes of IPv4 addresses. Now, within each of these different classes, you're going to have public addresses and private addresses. Public and private. Public and private. Remember we talked about public addresses versus private addresses? So you have public addresses, which can be in the Class A category, which can be seen from the outside. And then you've got private addresses, which can only be seen from the inside of that local area network. Okay? So as a quick overview, Class A is for large networks generally, and it's if your IP address starts from 1 to 126. All right, that's 1 to 126. Class B is for medium-sized networks, and it's if the first octet ranges from 128 to 129. And finally, Class C is for small networks, and that's if your IP address starts from 192 to 223. So you can see Class A has, about 126 available addresses there that you can potentially use, right? Whereas it gets smaller as we progress, hence that for large networks, for medium-sized networks, for small networks. We're going to get more into that in a second, but just know for the moment, it is categorized into these 5 categories, and within each category, you have specific reservations, specific reserved address ranges for private and public, all right? So there are some addresses that are only private IP addresses, and you cannot use that as a public IP address. We're going to have a look at what that is coming up. So the other types of IP addresses, we'll get into it, just keep that in your mind for now. The other type of IP addresses that we need to know about is public IP. Hopefully when I say that by now already, you should know what that is. It's accessible from outside your local area network, right? We have private IP, right? So we've talked about public. We also have private IP. So the public address is like your house. It's accessible from outside. You can see it. The private address is the address given to the individual devices within your house. You can't see that from outside your network. You can only see it from within. We also have a loopback address, which is essentially what you use for testing within your device. So it's, if you've got your device here and you want to actually send data back to yourself, so you're testing, can my device send data and can my device also receive data? You would use the loopback address, which is pretty much, especially for the sake of your exam, always going to be 127.0.0.1. That is your loopback address. And that's if you want to send data out and loop it back to yourself and also receive it. It's like you're a lonely kid. You're just trying to see, hey man, can I throw a ball and catch it? I just want to test before I go out and play with the other kids on the playground because they might make fun of me. That's your loopback address. Your broadcast address is basically when you want to send data to all devices in a network. So you're sending it, you can see all the arrows pointing all over the place, sending it to all devices. Generally, that's going to end with 255. That's generally going to be your broadcast address. So if you are on network 192.168.1, if you wanted to send data to every device on that network, you would generally send it to 192.168.1.255. That would be your broadcast address. Generally, the 255 is reserved for being that broadcast address. And you also have, this one you definitely need to know as well, APIPA, or automatically assigned, I can't remember what the other letters stand for, but basically the APIPA is when you can't find a DHCP server, it's not available, you can't find it, so you give yourself an APIPA address, right? You're like, hey man, I've joined a network, but oh shoot, I can't find a DHCP server, where are you? Right? Because the DHCP server usually provides you with an IP address. If you can't find it, you give yourself an APIPA address, and it always starts with 169.254. And then you'll have your actual your device host address. But if you want to know if it's an APIPA address, just look for 169. That's going to be your giveaway for APIPA. 169 is your giveaway, okay? So that's the different IPv4 addresses we need to know about, and we really need to be able to identify, right? They could ask you about any of these, and they could ask you like, hey, here's an IP address. Is this a public or private? Or they could say, hey, we're trying to find a loopback address. Which of the following IP addresses is a loopback? Or they might say, hey, John just got an APIPA address. Have a look at these IP addresses and find the APIPA address, right? They could really test you on any of this, and you'll need to be ready to do that, all right, unfortunately. Now, private addresses. I'm going to run you through over here real quick before I start reading through stuff. So this is your router, okay? Your router actually has that's right, two addresses. It has a public IP address that everyone on the outside world can see. It also has a private IP address, which everyone on your local area network can see. What people will do if they want, or what data will do, right? What devices will do if they want to communicate. Let's say I've got my friend John, and he wants to send data to my laptop over here, okay? He doesn't actually know this IP address because this is a private IP address. So what he has to do is he has to say, hey, man, I want to send data to this device. So he will send it to the public IP address. And then the router will say, okay, I've received this on my public end. I now need to translate this and send it from my private IP address over to this device here. Okay, so the router translates from public, it receives data on its public IP address, translates it over to its private IP address, where it sends it from its private IP to the device it was actually targeting to. Now, you may be asking yourself, wait, how does it do that translation? Guys, don't worry about it. I'm telling you now, you're doing your A+, wait till you get to your Network Plus to worry about that stuff. It is something called oops, I just crossed it out. It's something called Network Address Translation, or NAT. You can go Google it more if you want to, but I'm telling you, that is past the scope of this exam, truly. What you need to know is that your router has a public IP, a private IP, it receives data on the public, and it sends it out to your local area network on the private. That's largely what you need to know there, okay? That's how that works. Now, the private ranges within each of these classes, guys. Remember, we have our Class A address. We talked about our Class A. Any IP address starting from 10, really, I guess for simplification, we can just say any IP address that starts with 10 is going to be a Class A private range. Any IP address that starts with 172.16 and goes to 172.31 is going to be a Class B private IP address range. And again, any IP address that starts with 192.168 and goes to 192.168 to the end of that, right, 255, because that's the largest number you can have, is a Class C range. So again, guys, you're going to need to make sure that you can identify not only what range it is it a Class A, Class B, or Class C address, but you'll also need to be able to say, is it a public or a private address? All right, you will need to be able to do that. I'm going to do my best to help you be able to do that, but you are going to need to be able to do that. Now, public addresses is something that we have been over. We've talked about that concept of public addresses. We did it over here with the router. So every local area network, every house that you could possibly think of, right, they have a public IP address, and they've got one public IP address for that particular network, which allows data to be sent through and access the private IP addresses on the inside. And because that whole network only has one public IP, it allows us to conserve our available IP addresses, okay? So that's one of the good benefits of that. Now, that's pretty much it, guys. We really know everything we need to know about that, to be honest. The main things you need to know in terms of IP4 addresses, right? Here's the stuff you really need to know. You need to be able to describe what an IPv4 address is used for. You need to be able to actually see one and recognize that an IPv4 address is what you're looking at, and you'll need to be able to distinguish it from an IPv6 address and a MAC address. So you need to look at it and be able to say, that's an IPv4 address. You'll also need to be able to state if an IP address is in class A, B, C, D, or E, and the public and private ranges within those classes. Now, the most common ones you're going to be tested on is really A, B, or C. The others you may be, I showed you before, you can go back and have a look. I'll show you again in a second, but A, B, and C is the most likely ones you'll need to have a look at. Now, here's a nifty little table for you, okay? This lays out the classes, including the APIPA and loopback addresses. It also tells you within that class, the public addresses. So this is class A, public addresses are in this range. However, there is the exception of the private addresses. So class A public addresses is everything from 0 to 126. But within that range, anything starting with a 10 is a private address. Similarly, class B is everything from 128 to 191. But anything starting with 172.16 and going to 172.31 is a private address, etc. So pause this, have a look at this table. This is another one of those tables. Yes, you should be able to draw this from heart. I'm sorry to say it, but you're going to have to be able to do it, guys. I'm really, really sorry to be the bearer of bad news, but I am. IPv6, guys. Basically, it is, remember IPv4 was 32 bits long? IPv6 is 128 bits long. And what that means is it can support 340, are you ready for it? Undecillion unique addresses. So there's a lot more space. With IPv4, we're worried about running out of space. IPv6, we really don't have to. Long story short, IPv6 looks something like this, okay? It's a combination of letters and numbers. And if you get to a point where you've got a lot of zeros next to each other, you can actually just do this to shorten the address. So it's just easier to read, easier to look at, easier to interpret. But long story short, guys, if you've got an address that is grouped in 4, it's 8 groups of 4, with the exception of using those double colons if it's all zeros. 8 groups of 4, right? You've got 1, 2, 3, 4, 5, 6, 7, 8. 8 groups of 4, and it's a combination of numbers and letters. That's going to be IPv6. It's pretty easy to recognize. For this, you just need to know why it's what the benefits are in relation to IPv4 and what it looks like. You don't need to know the specific loopback addresses or any of this stuff. Okay, you just need to be able to look at it, recognize it, and say that the advantage is it supports way more addresses than IPv4. Okay, that's pretty much it. Now, a APIPA address, we've talked about it briefly, but basically, you can pause and read the notes, but an APIPA address is essentially your device has connected to a network and it's like, hello, is there any DHCP server out here? But I can't find a DHCP server, man, it's alone. So it gives itself an APIPA address, which always starts with 169.254, and then you'd have a number over here, right? That would be your host number, okay? But if you see the number 169 at the start, especially 169.254, but generally 169 is going to be a dead giveaway that it's an APIPA address, which means you have not been able to connect to a DHCP server. So they may ask you, hey man, I've been trying to connect to your network, but I've received this IP address. What's wrong with it? And then you have a look and it says 169.254. You're like, oh, you couldn't find a DHCP server. Let's have a look at what's going on. You've got an APIPA address, right? That's pretty much the extent you'll need to know about for your exam. And then you've also got static. So a static address, you don't even use a DHCP server. You actually have a human being, a real life human being, go over to the address and manually configure it. So you go over and you log into the machine and you configure it on the machine. That's the key, guys. A static address is configured on the machine, which is why he's saying, I'm special. Everyone else uses a DHCP server or a reservation on a DHCP server, but this guy actually came to me specifically. Now, why would you do this? If it's an address that you know is always going to stay the same and generally always needs to be active. So think about printers. You can't have the IP address of a printer change. It's good to manually set it so that nothing can go wrong and the IP address can't change, right? You would set a static IP address. Anything that you need to be static and stay the same, static IP address, you'd want to configure it on the manual device itself, okay? And then dynamic is just what we've always talked about in relation to a DHCP server. Your device joins the network, it finds a DHCP server, you say, hey, can I please have an IP address? He says, sure. He looks at his pool of available addresses, he says, do you want this one? You say, yes, beautiful, you have one. It's going to change every time you join the network, right? You're leasing that IP address. We've talked about it already. Pause and read if you want to, but we've really gone through that plenty, I think, so far. And finally, your subnet mask. You do need to know this. What a subnet mask is, essentially, it's just a way of identifying, when you look at an IP address, what portion of this IP address belongs to the network, which portion of this is saying, oh, this is the network you belong to, and which portion is actually telling me which device you are on that network. So in this case, everywhere there is a 255, and for your A+, it's always going to be as simple as 255, so it can be more complicated than this, but for your A+, this is really, honestly, it's all they're going to give you. Like, if they give you any more than this, I will tell you where I live, and you can come kick me straight in the face. That's how confident I am in this, okay? So what this is basically saying is, if you have an IP address of 192.168.100.15, and your IP address is 255.255.255.0, everywhere there's a 255, that's essentially like it's masking that portion of the IP address, which is basically saying if there's a 255 where that number is, that belongs to the network, okay? That belongs to the network. So in this instance, this IP address, when we look at the network mask, we can actually see, okay, 255.255.255.0. Okay, so the first three numbers is telling us that that's just the network they are on, which is why we have this dividing line here, right? We've got this dividing line. Everything, the first three numbers is the network, and then where it says 0, that's saying, oh, that is not masked. So that means only the last number is the actual device's IP address. Okay, only the last number is the device's IP address. So, for example, if this was, so in this instance, shall I say, the network is 192.168.100, but the device's IP, the device number, is 15. So it is the 15th device on this network. So if you had an IP address, the same IP address actually, if you had the same IP address, let's just quickly give you a little quiz. You had the same IP address, and instead your network mask was this. Take a quick little second and think to yourself, okay, actually, maybe I should I'll get rid of this for the second. All right. Based on this, what I just told you, what portion of the above IP address is the network, and what portion of the above IP address is going to be the host, the device IP? Take a few seconds, pause the video. I'm going to tell you now. All right, we've got 255.255. So that means the first number, this is 255, so 192, that is masked. So that is the network. 255, yep, that is masked. So that is the network. 0 and 0. Okay, so the first two numbers are masked, which means the first two numbers is the network portion. And the next two numbers are not masked, which means these two numbers, or this portion of the IP address, in this case, is the device IP. You really probably won't need to know that level of specificity for your A+ exam, but just know the subnet mask helps you identify what portion is the network and what portion is the device's IP address. That's pretty much what you need to know, guys. And finally, the gateway. I keep saying finally, I know. I keep thinking we're at the end, but then I realize I got more to go. My bad. I know I'm getting you excited. The gateway is essentially just another word for your router, because remember, your gateway, your router, is the only way information can travel in from outside and get to your private IP addresses, and it's the only way you can get information from inside out into the big wide world. So if this guy wants to send data through to the big wide internet, he has to go through the router, and the router then has to send that off to somewhere else. It's the gateway, all right? That's the main thing. Gateway is the router, all right? That's what you need to know, really. All right, guys, got some questions for you. Ready to go. Let's have a look at how we go. Let's have a look at our IP addresses. The question reads, An organization is setting up its internal network and has chosen the IP address 172.16.45.78 for one of its servers. Based on the IP4 address classifications, which class does this IP address belong to? Class A, Class A, B, Class B, C, Class C, or D, Class D? Pause the video if you need more time. I'm going to get straight to the answer, guys. 3, 2, 1. The answer here is Class B. It's B, Class B. So, guys, it's just as simple as knowing these classifications off by heart. You got to be able to draw that table that I paused on earlier in this video, the table that showed all the different classifications and the private and public IP addresses. You really got to know that off by heart. It's that simple. When I was studying this, I took a little sheet of paper. I went shopping with my wife, and I'd read it, and I'd try to recite it. And then my wife would ask me to give her a can of chickpeas, and then I'd, okay, now I forgot. Now I'll try to recite it again, check if I was right, check if I was wrong. I'd do that over and over and over again until eventually, really eventually, I got it, okay? Next question, it reads, your IT department assigns the IP address 10.45.23.78 to one of the devices in the company's network. Based on IPv4 classifications, is this IP address public or private? And which class does it belong to? That's a tricky one. A, public and class A. B, private and class A. C, private and class B. Or D, public and class B. Your answer coming in 3, 2, pause the video if you need more time. 1, we're getting straight to it. The answer is B, private, class A. Remember, anything starting with a 10 is private, and it falls within that class A address range. We just need to know our private addresses within our class A, B, and C's. 100%. Again, we just got to memorize that table, guys. There's nothing much more for me to say on that. Next question reads, Emma is troubleshooting network connectivity issues in her office. To diagnose the problem, she gathers information about her computer's network settings. She records several identifiers and needs to determine which of these represents the IPv4 address used for communication within the local area network. Which identifier should Emma choose? A. I can't read this out to you guys. You'll have to pause the video and have a look. It's too tricky. Pause the video, read it, make a guess at the end. Say what you think the answer is. Jesus Christ. It's been a long day, and I've got home from work, and I'm 2 videos in, guys. I'm trying my best to keep it together over here. The answer coming in 3, 2, 1. Let's have a look. The answer is 192.168.1.100. So Emily was looking for the IPv4 address used for communication within the local network. Let's have a look at the question. She's troubleshooting network connectivity issues in her office. To diagnose the problem, she gathers information about her computer's network settings. She records several identifiers and needs to determine which of these represent the IPv4 address. So this question can essentially be translated into, which one of the following is an IPv4 address? This one cannot be, because we know an IPv4 is 4 numbers, each of which is separated by 1 dot, and it doesn't contain any letters. This one is 4 numbers, each of which is separated by a dot. That could be it. This one, it's 1, 2, 3, 4, 5, 6, 7, 8, and it has numbers and letters. That can't be it. And that's a website URL. So this is our IPv4 address, okay? We have to be able to read through all that fluff and translate the question into basically giving us the important details, which is which of the following is an IPv4 address, and that is what an IPv4 address looks like. Right? You should be able to answer a question like this and be able to identify each of these. All right, next question reads, Sarah is troubleshooting her computer's network connectivity and wants to test whether her device can communicate with itself. To do this, she needs to use the loopback address, which is specifically designated for internal testing on a device. Based on the following IP addresses, which one is the loopback address? A, 10.0.0.1, B, 127.0.0.1, C, 192.168.1.1, D, 169.254.1.100. Pause the video, take a guess, answer coming in 3, 2, 1, here we go. Your answer is B, 127.0.0.1. Sorry, 127.0.0.1. I'm falling to pieces over here, guys. All right, so yeah, you'll need to know your loopback address, and you'll also need to know your APIPA address, all right? which in this case would have been 169.254. That's how you can identify that. So guys, hopefully, should I do this? Oh yeah, I'll do another one for you. Okay, next question reads, Sophia is configuring her network settings and notices that her computer's IP address changes each time it connects to the network. Which of the following best describes this type of address? A static address, B, a loopback address, C, a dynamic address, or D, an APIPA address? Pause the video if you need more time. Your answer coming in 3, in 2, in 1. Here we go. It is C, a dynamic address. If it's changing every time you connect, it means the DHCP server is giving you a new IP address from within its available IP addresses that it has every time. A static address is when you manually configure it on the machine. A loopback address is when you send data to yourself to test if your device can send and receive data. And an APIPA address is when you cannot connect to a DHCP server and you give yourself an automatic IP address. That APIPA address. So guys, look, if you want to get a free practice exam, click the link in the description or in the pinned comment. If you made it this far, you may as well, guys. You clearly are actually trying to make sure you pass your A+ if you made it this far into the video. So go ahead, grab your free practice exam. It has 3 performance-based questions, 90 multiple choice questions, and if you see that and you like it and you actually want to get the full learning guide, which has a full learning guide which breaks everything down by exam objective, gives you notes, gives you active recall questions, gives you multiple choice questions, everything you've seen here. Also gives you 11 performance-based questions, then you'll love that. You also get 3 full-length practice exams, which is the same questions you get through the learning guide, but just in a randomized order in an exam format. You also get an interactive troubleshooting performance-based question simulations. It's really cool. You can actually click on the buttons and work your way through it. So once you've built that foundation, you can really test yourself with that. And I actually also give you a spreadsheet to track your progress. This guy says, your notes definitely helped me pass my test today. That was on my old one. That was not as good as this. So if this helped him, then I guarantee you 100% this will help you. So this is an example of what it looks like, right? I break it all down into the actual exam objectives. As you can see there, for every exam objectives, you get notes, multiple choice questions, everything I was talking about before, and it's broken down in really a lot of detail. I don't only break it down into the exam objectives, I actually break it down into the dot points itself on the exam objectives. Okay, so really a lot of detail there, guys. A lot of detail. You get just so much value for money here. You get multiple choice questions, you get detailed answers, you get performance-based questions, 11 of them. You also get a video where I tell you how to use 2 free AI tools to 10 times your learning. So once you've identified your weak areas, you can follow the instructions in this video and actually really quickly make progress, way faster than you otherwise would. And I also give you another video. Are you kidding me? Look at all this stuff I'm giving you. I give you another one about how to use multiple choice questions to actually study to make sure you're ready, because most people don't use them correctly and they get to the real thing and they are just not prepared. All right, so this is an example of the interactive clickable troubleshooting performance-based questions. You've got questions in all of these categories for your troubleshooting. For this one, you can click on all of these photos. Each person has a problem you need to try to solve, identify the issue, choose the most likely issue. This one has some issues with a laser printer. You click on this and you try to solve the issues. You click on the inkjet printer, you try to solve the issues. All right, so all of that over at journeytocyber.com. It helped this guy pass. It helped a bunch of people pass. I got heaps of reviews there over on my website. You can check out the screenshots. But that's about it, guys. I'll see you in the next video. Can't wait for you to finally pass this exam and let me know that you did in fact pass it. Honestly, I'm so keen to hear from you guys. Leave me a comment when you eventually pass, okay? Because you will, and I know you will. See you guys, and yeah, see you in the next one.